Welcome to Simplifying Radicals. So what we're going to talk about, simplifying radicals, it's similar to when you have a fraction that you have to reduce a fraction. So what we're doing, it's any time that you have a radical, so anything that has a square root, you have to pull out the perfect squares. But what I do is I have a simple and easy way for you to figure out what your perfect squares are. So what do? Basically, I explain it like pulling a pair of socks out of the dryer. So remember, when you do your laundry, you always lose socks. There's always a sock that has an odd pair. So you always pull your pairs of socks out of the dryer. Whatever doesn't have a pair, you leave in there. So we're going to make a factor tree. So for whatever number is in the radical. And then we're going to pair up the numbers that match. And then they go on the outside, so they come out of the dryer, and then numbers that don't have a pair, they go on the inside. So let's show you what I mean. So first thing we do, if we want to simplify the square root of 24, so basically in any problem that you have, if you're square rooting something, you now have to complete your answer like this. So we're going to make a factor tree for 24. So that just means pick any two numbers that multiply to give you 24. You could use 2 and 12, you could use 8 and 3, you could use 6 and 4, it doesn't matter. I'm going to go ahead and use 6 and 4. And then I want to go ahead and find out, well, I want to break down the 6 and the 4. Well, 6 becomes 3 times 2, 4 becomes 2 times 2. Now, all four of those numbers are prime numbers, so that's the end of the factor tree. But what I want to do is I want to pair these up. So it's like I have a 3 sock and then 3 2 socks. So what I do is I pair up what I have. So a pair, of course, would be 2. So I'm going to circle what I have a pair of, and that goes on the outside of the dryer, so that's my socks. And then my dryer is the square root, and what goes on the inside is what did not have a partner. So that would be your 3, and then it would be multiplied by 2, or it just comes out to be 2 square root of 6. And that is simplifying a radical. So let's go on here. What happens if there's variables inside there? Because, of course, it's algebra, we're going to have variables. We basically do the same thing. We just think about how many variables we have, and we pair up the variables as well. So what we're going to do is we have the square root of 36x to the 7th. Well, 36, I can do, we'll say, 4 times 9. The 4 breaks down into 2 2's. The 9 breaks down into 2 3's. So I'm also going to think of the x when we have a 7 as an exponent. Please remember the long way. That means I have 7 x's. So 1, 2, 3, 4, 5, 6, 7. So for my pairs of socks, I have a pair of 2's. I have a pair of 3's. So when they come on the outside, that would be 2 times 3. Now, before I figure out what stays in the dryer, I need to also pair up my x's. So I have 1 pair of x's, 2 pair of x's, 3 pair of x's. So that means when it comes on the outside, it's going to be x cubed, because that 3 means I had 3 x's. Then I'm going to draw my radical, my dryer, and I look at the numbers, and I see, well, there was no numbers left. I only had the 2's and the 3's. But with the x's over here, I see I had a single x left. So I'm going to go ahead and just put a single x. So then multiply this out. 2 times 3 would be 6x cubed square root of x. And then that's my answer there. So let's go on, because of course there's more to this. So what if we have bigger than square roots? Because there are things like cube roots, there's fourth roots. So what I think about is, instead of just having 2 for a pair, it's like we have a 3-legged alien here. So that means I match up 3 if it's a cube root. If it's a fourth root, that means I would need 4. So like maybe we're putting socks on a dog or something. So let's go on. And I want to look at the root. So in this case, the root is a cube root. So I'm going to break down the 16. I know 16 is 8 times 2. And 2 is a prime. So the 8 is a 4 times 2. That 2 is a prime. And then the 4 is a 2 times 2. And then the x because I have that number there, that means I have 4 x's. So 1, 2, 3, 4. And then because I have the 3, that means I need groups of 3. So I now circle 3 2's. So when I write it down, I only write down a single 2 because that's one group of 2's. And I can circle 3 x's, which again means I write down a single x because there's only one group of x's. When I write down the radical, you need to make sure that you still have that 3 there for your cube root. And then what I have left is a 2 and an x because that is not in the circle. So on the inside I put down 2 and x. I have nothing left here to multiply, so that is my answer. So let's go ahead and try that one more time. When I look at this one, I see that I have a 4, so it's a 4th root. So when I break this down, 243. I know 3 goes into there 81 times, so 3 times 81. And then the 81 will break down into a 9 and a 9. This 3 does not break down because it's prime. And then these 9s break down into 3's. 3 and 3 and 3 and 3. So because of this one, I need a group of 4. So let me go ahead and write down my 6 x's. 1, 2, 3, 4, 5, 6, and my 8 y's. 1, 2, 3, 4, 5, 6, 7, 8. And now when I circle these, I need groups of 4. So I see I have one group of 3's. I have one group of 4's. And I have 2 groups of y's. So I always have to write the number down first. So I had one group of 3. So again, I don't write down 4 3's. I just write down a single 3 because there's one group. And then alphabetical order, I have a single group of x's. And because I have 2 groups of y's, I go ahead and put y squared. Again, because this is a 4th root, it's very important to keep that 4 above the root there. And then I need to write down everything that did not have a partner. So I have the 3 here, and I have 2 x's here. So on the inside, I have 3 and then x squared, and that is my final answer. So I want you guys to please go ahead and look at these and see if you can try it yourself.